This is a review of our topics from this week. We are going to look at simultaneous equations, the equation of a line, and sequences. Simultaneous equations. We can solve simultaneous equations by elimination. To do that, we need to make the x's the same or the y's the same. So we can either make the x's the same or the y's the same. So for this question here, question 1, I could make the x's the same by multiplying the top equation by 2 and the bottom equation by 3, and that would give me 6x for both of them. Or I can make the y's the same by multiplying the top equation by 3, and I'll have 3y for both of them. So I'm going to do that. I'm going to multiply every term in the top equation by 3. So that would be 9x minus 3y equals 60. And I'm going to leave my second equation as it is. 2x plus 3y is 6. Now, my y's aren't exactly the same. I've got a negative 3y and a positive 3y. So I'm going to get rid of them by adding them together. I'm going to add my top equation and my second equation together. If they had the same signs, if they were both positive, I would get rid of them by taking away. Let's go through this one by one. So 9x plus 2x, adding the x's together, it gives us 11x. For the y's, negative 3y plus 3y is nothing. That's gone. And 60 plus 6 is 66. So 11x's are equal to 66. If we divide both sides by 11, that gets x by itself, and x is 6. So we know what x is now, and we can use that to find y. So I'm going to substitute this 6 into one of my equations. It doesn't matter which we use. I'm going to use the second one. So we know 2x plus 3y is equal to 6. But x is 6. So I can change x to 6. So I've got 2 6's plus 3y is 6. 2 6's are 12. So 12 plus 3y is equal to 6. If I take 12 away from both sides, I get 3y is equal to negative 6. I then divide both sides by 3. So y is by itself, and y is negative 2. So x is 6, and y is negative 2. And that should work for both of these equations. So if the top one, 3 6's are 18, take away negative 2. So when you take away a negative, you add 18 plus 2 is 20. So we know we've done it right. X is 6 and y is negative 2. Question 2. Again, we want to get rid of either the x's or the y's. And to do that, we are going to make them the same. So we can either multiply the top by 5 and the bottom by 4, which make the x's the same. Or I could multiply the top one by 3 and the bottom one by 2 and make the y's the same. I'm just going to make the x's the same. So I'm going to multiply every term in the top equation by 5. So 4x times 5 is 20x. 2y times 5 is 10y. And 2 5's are 10. And the bottom equation, 5 4's are 20. So the x's are the same. 3 4's are 12. And 5 4's are 20. So I've got the x's the same. To get rid of them, we're going to take away. So we're going to do the top equation, take away the bottom equation. So 20x take away 20x is nothing. Negative 10y take away negative 12y. So when we take away a negative, we go up. So it's negative 10y plus 12y, which is 2y. And 10 take away 20 is negative 10. So 2y is equal to negative 10. Half both sides, divide both sides by 2. So y is negative 5. So we know what y is, so we can substitute that into our top equation to find x. So y is negative 5. So we're going to change y into negative 5. Substitute negative 5 in for y. So we have 4x. We've got minus 2 times minus 5. Negative 2 times negative 5 is a positive 10. So now we're solving an equation. So we're going to take 10 away from both sides. So 4x equals negative 8. And divide both sides by 4. So x is negative 2. So we've got y is negative 5 and x is negative 2. And we can check that in our other equation. So 5 negative 2's make negative 10. Take away 3 negative 5's. So when we take away a negative, we go up. So it's negative 10 plus 15, which is 5. The equation of a line. The equation of a line is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So this first question, question 1, we've got y equals 5x minus 2. So the gradient, the m, is what goes with the x. So the gradient is 5. And the y-intercept is negative 2. So for every one it goes across, it goes up 5. And it crosses the y-axis at negative 2. Question 2. Write down the equation of a line parallel to y equals 2x plus 1. If lines are parallel, they have the same gradient. So the gradient of this line is 2. So any line with a gradient of 2 is parallel to y equals 2x plus 1. So we can write y equals 2x and then plus or minus anything. And it would be a parallel line. Parallel lines have got the same gradient. And this time we're finding the equation. So we've been given the lines and we're going to work out the equation. So let's look at this red line. The gradient is for every one it goes across, how much it goes up or down. So this red line goes across 1, up 3. So it's got a gradient of 3. Its y-intercept, it crosses the y-axis, is at 4. So the equation of a line is in the form y equals mx plus c. So for this red line, we've got y equals 3x plus 4. For the green line, for every one it goes across, how much does it go up or down? So we can see that it goes across 3 and down 1. So for every one it goes across, how much does it go up or down? If we do the change in the y, which has gone down 1, divided by the change in the x, which is 3, we can get the gradient. So it's negative a third. For every one it goes across, it goes down by a third. Its y-intercept at 0. So its equation is y equals minus a third x. You don't have to write plus 0. If its y-intercept at 0, you just don't write anything on the end. And the purple line, for every one it goes across, it goes up 1. So its gradient is 1. It crosses the y-axis at negative 1. So its equation is y equals 1x minus 1. So y equals x minus 1. We don't have to write 1x. Question 2. find the equation of the line that passes through the points 2, 3, and 6, negative 5. To find the gradient of a line, we can do the change in the y's over the change in the x's. The change in y over the change in x is the gradient. So we can label our points x1, y1, x2, y2, and substitute them into this formula, the change in y over the change in x. So y2 is negative 5, so negative 5 minus 3 over x2 minus x1, 6 minus 2. So we've got negative 5 minus 3, which is negative 8, over 6 minus 2, which is 4. 8 over 4 is 2, so negative 8 over 4 is negative 2. So the gradient is negative 2. For every 1 it goes across, it goes down 2. So we've got y equals negative 2x plus c. We need to find the y-intercept, and we can do that by substituting a set of coordinates, an x and y, into this equation. So x is 2, y is 3. So substitute them in. So we're going to change y to 3, change x to 2. Negative 2 times 2 is negative 4. So 3 equals negative 4 plus c. To get c by itself, plus 4 to both sides. So c is equal to 7. So the equation of the line is y equals negative 2x plus 7. And we can check that by substituting in the coordinates and making sure it works. So if y is negative 5, so we'll have negative 5 equals negative 2 times 6 plus 7. Negative 2 times 6 is negative 12. Negative 12 plus 7 is negative 5. So it works. And sequences. The nth term of a sequence, so the position to term rule, is 4n plus 5. Write down the first 5 terms. So the first term of a sequence is when n is 1. So 4 ones, 4, plus 5 is 9. The second term is when n is 2. 4 twos are 8, plus 5 is 13. The third term is when n is 3. 4 threes are 12, plus 5 is 17, and so on. But we can see this sequence is going up in 4s, so we can just add 4 and add 4 again. So they are the first 5 terms. Is 65 in the sequence? So if 65 was in the sequence, there will be a number for n that makes 4n plus 5 equal to 65. So if we make 4n plus 5 equal to 65 and solve it, if we get a whole number answer for n, we'll know it is in the sequence. And what we get for n will be the term it is. So let's solve this. Take 5 away from both sides. So 4n is 60. And then divide both sides by 4. So n is 15. So yes, it is in the sequence, and it is the 15th term. Question 2. Find an expression in terms of n for the nth term. So we've got the sequence, and we need the nth term. So we look for what it's going up in. So it's going up by 6 every time. Adding 6 is the term-to-term rule. To get from one term to the next term, you add 6. So because it's going up in 6s, we say that's 6n. And 6n is the 6 times table. So the 6 times table goes 6, 12, 18, 24, 30. But our sequence is not the 6 times table. What do you have to do to the 6 times table to get our sequence? You have to take away 2. the sequence is always 2 less than the 6 times table. So it's 6n take away 2. So that was our review. There's an assessment now available. The link will be in the description or at the bottom of the page on the website.